Chapter 1, Section 3, Segments and their measures. The first thing we need to talk about in this section is a postulate. A postulate is a rule that is accepted in geometry without proof. It may also be called an axiom. We're going to use postulates and theorems later on to write proofs, but for right now we're going to use postulates to solve problems. The segment addition postulate says that if B is between A and C on a segment, then segment AB plus segment BC equals the whole segment AC. It also says that if AB plus BC equals AC, then B is between A and C. An illustration of this postulate would be having segment AC with B between A and C. This postulate says that segment AB plus this segment BC will equal the whole segment AC. To write a segment addition postulate, it asks us to write a segment addition postulate for a segment where E is between D and F. Go ahead and draw yourself a segment where E is between D and F. The segment addition postulate would say that DE plus EF equals the whole segment DF. The segment addition postulate example 1 says that two friends leave their homes and walk in a straight line toward the other's home. When they meet, one has walked 425 yards and the other has walked 267 yards. How far apart are their homes? Draw yourself a picture if you need to. Here I have two houses. One friend is walking 425 yards. The other friend has walked 267 yards. Using the segment addition postulate, I can find the distance between their homes. Add together the distances they walked, so 425 plus 267 equals 692 yards. Segment addition postulate example 2 says that a car with a trailer has a total length of 27 feet. If the trailer has a total length of 13 feet, how long is the car? Draw yourself a picture if you need to. Here I have a car with a trailer. The total length of both combined is 27 feet. It says that the trailer has a length of 13 feet, and then it asks us how long is the car. Using the segment addition postulate, I can say that the car length, x, plus the trailer length, 13, equals the total length, 27. Now it's just solving a one-step equation. Remember, you do the inverse operations, subtract 13 from both sides, and you find that x equals 14 feet. So the car is 14 feet long. Segment addition postulate example 3 says that suppose M is between L and N. Find the lengths of LM, MN, and LN. Given LM equals 3x plus 8, MN equals 2x minus 5, and LN equals 23. Again, feel free to draw yourself a picture. It's easier to see that way. Here I have segment LN, where M is between L and N, and label what you know. It tells me that LM is 3x plus 8. It tells me that MN is 2x minus 5. And it also tells me that the whole thing is 23. Using the segment addition postulate, I can say that 3x plus 8 plus 2x minus 5 equals the whole segment 23. Combine your like terms and you get 5x plus 3 equals 23. When you solve for x, you find that x equals 4. I have not completed this problem yet because it asks me to find the lengths, not to solve for x. Now I need to go back in and plug in 4 for x to solve for LM and MN. So For LM, I do 3 times 4 plus 8. 3 times 4 is 12, plus 8 is 20. For MN, I do 2 times 4 minus 5. Well, 2 times 4 is 8, minus 5 is 3. A way to check your answer is to go back. The whole segment, LN, is 23. I know that the part LM is 20 and the segment MN is 3. So your two segments, 20 plus 3, should equal 23. That is true, so my answer could be correct. The distance formula says that if A and B are points in a coordinate plane, then the distance between A and B is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Notice the sub 2's and sub 1's. That simply means that x sub 2 and y sub 2 come from the same ordered pair, and x sub 1 and y sub 1 come from the same ordered pair, or the same point. You should have seen this in the slope formula when you're calculating the slope and given 2 points. An example using the distance formula asks us to find the lengths of the segments. It also asks us to tell whether any of the segments have the same length. If you notice on this coordinate plane, we're shown 3 different segments. We need to find the length of each using the distance formula. The first segment we can find the distance of is EF. So I'm using the point -3, 3 for E and 1, 2 for F. Plug it into the distance formula. I have the square root of 1 minus -3 squared plus 2 minus 3 squared. You can have them in different orders. You will get the same answer. It's just important that your first x and your first y come from the same ordered pair, and your second x and your second y come from the same ordered pair. Go ahead and do what's inside of the parentheses. I get the square root of 4 squared plus -1 squared. Go ahead and square 4 and -1. You get the square root of 16 plus 1. So our final answer for the length of EF is the square root of 17. That radical cannot be simplified because there's not a perfect square that goes into 17. Now I'm ready to find the length of segment FG. This time I'm using the point 1, 2 for F and the point -3, 0 for G. Plug it into the distance formula. The square root of 1 minus -3 squared plus 2 minus 0 squared. Again, you can have them each inside of each parenthesis. You could have it flipped. Other than that, though, your x and your y from F need to be either first or second, and your x and your y from G need to be either first or second. Do what's inside of the parentheses. You get the square root of 4 squared plus 2 squared. Go ahead and square both 4 and 2. You get the square root of 16 plus 4. Well, 16 plus 4 is 20. This time it is not my final answer because there is a perfect square that can go into 20. The perfect square that can go into 20 is 4. So the square root of 4 is 2, and the square root of 5 is left inside. If you're having problems simplifying radicals, you need to make sure that you see me and we can get it figured out before we get too far into this. The last segment is GH. For G, I'm using point -3, 0, and for H, I'm using the point 0, -1. Plug it into the distance formula. I have the square root of -3 minus 0 squared plus 0 minus 1 squared. Doing what's inside of the parentheses, I get the square root of -3 squared plus the square root plus -1 squared. Well, -3 squared is +9, and -1 squared is 1. 9 plus 1 is 10, so our final answer is the square root of 10. I have not answered this question yet because it asks me to tell whether any of the segments have the same length. Well, the square root of 17, 2 square roots of 5, and the square root of 10, none of those are the same, so none of these segments have the same length. What are congruent segments? Congruent segments are segments that have the same length. So if we go back and we look at our problem that we just solved, we can say, instead of saying none of these segments have the same length, we can say none of these segments are congruent. Today's assignment is on page 21, numbers 20 through 38 even.